All right, so today we're going to look at section 6.4, which is on three special shapes that all fall under parallelograms: rhombuses, rectangles, and squares. Okay, so any properties we already know about a parallelogram automatically apply to rhombuses, rectangles, and squares. Okay, we had 4 or so major properties about parallelograms we talked about in section 6.2 and 6.3. Can anybody tell me one of the 4 things that's always true in a parallelogram? Yep?
The sides are parallel.
Yeah, it's opposite sides are parallel. Good, by the definition. So in a rhombus, a rectangle, and a square, opposite sides are parallel. Yep. So that's the definition. And how about one of the other 4 things? Yep.
Angles add up to 360 degrees.
Okay, all their angles add up to 360. That's true for any quadrilateral. Good. Okay. What else?
They have 4 sides.
Yep, so I'm looking for things that are specific, though, to parallelograms.
Oh, I thought that.
So 4 sides could also apply to like trapezoids and kites. But what's something special about a parallelogram?
They have angles.
Yeah?
Opposite sides are congruent.
Opposite sides are congruent. Yes. Okay. In a parallelogram, we learned opposite sides are congruent. That's also true in a rhombus, a rectangle, and a square. Okay. What else? What's something else that was always true in a parallelogram? Opposite sides, the ones we just went through. Opposite sides are congruent. What else? We have things about the diagonals, things about the angles. What else? What about one of those things? Yeah?
Opposite angles are congruent.
Opposite angles are congruent. Okay? So in a parallelogram, opposite angles are congruent. So in rhombuses, rectangles, and squares, opposite angles are congruent. What about the diagonals in a parallelogram? What happens there? Yeah. Yeah, they bisect each other. So if you draw diagonals in a rhombus, a rectangle, or a square, they bisect each other. All right, so those are some of the general kind of ideas that apply to parallelograms. We're going to look at some more specific ones in a few minutes. Okay, so here's our definition of a rectangle. Now there's other characteristics about a rectangle, but this is the definition. It's a parallelogram with 4 right angles. So technically there might be another shape that falls under that as well, like a square. Okay, but if you just tell me this, I have a parallelogram with 4 right angles, I at least know it's a rectangle. You haven't told me anything about the sides. Maybe it's a square, I don't know. But it's at least a rectangle. Okay, now if you said you had a parallelogram with 4 congruent sides, at a minimum, that means it's a rhombus. Okay, it's a parallelogram. It's got 4 sides, all the same length. It's at least a rhombus. What shape might it be, but I don't have enough information to determine that yet. Could be a square. You haven't said anything about the angles yet. Okay. But if you've got a parallelogram with 4 congruent sides, that's a rhombus. Yeah. And then if you put kind of those 2 definitions together, if you have a parallelogram with 4 congruent sides and 4 right angles, that's a square.
If you didn't say 4 right angles, does that make it a rhombus?
If it just had the sides, that's a rhombus. Yep. Yep.
What if it had 3 right angles?
Well, in a quadrilateral, if you had 3, that automatically means you have 270, and they all add up to 360. So then the 4th one has to be 90. Yeah. Okay, even if they didn't label all of the sides and angles, using congruent triangles, we could figure out some of the other angles or the fact they all add up to 360. Like if you drew that diagonal in, and let's say they didn't label that angle. Well, I know that side is congruent to itself. So this triangle and this triangle are congruent by side, side, side. So if that angle's 90, that angle's 90. So there's all kinds of things we can do with congruent triangles. Okay, any questions on that? Okay, everyone have those three definitions? Right, so that's probably something I'll ask you about on a test. I might say, can you prove the following figure is a square using the definition? There might be other ways to prove something's a square, like you could use slope. Make sure that these lines are, what do you call two lines that meet at a 90? You're talking about the lines themselves?
90-degree intersection.
But what's that called? Two lines that intersect at a right angle. Perpendicular, yeah.
Perpendicular.
Okay. So if you could prove that angles or lines are perpendicular, that might be a way to help show that you have 90-degree angles. Okay. Using your distance formula, you could find the length of the sides. Okay, it's a little time-consuming, but you could go through and do it. Okay, so keep in mind those formulas as we do proofs. All right, so here's a kind of simplified diagram just of parallelograms. Okay, it doesn't include trapezoids or kites or anything like that. Okay, so under parallelograms, here's your three shapes. Okay, rhombuses, one category. Rectangles is another. And then the overlap, if something is both a rhombus and a rectangle, it's a square. Okay?
Mr. Hager,
Yes.
why did you have to color code it?
Because the colors doesn't matter.
Yeah, just, I don't know, make it a little easier to see, I guess.
The color red.
Okay, any questions on the relationship between rhombuses, rectangles, and squares?
When you put the yellow over the purple,
Yeah, that's what it does automatically. Yeah, yeah. Yep.
very high.
All right, so now using that diagram, I got 4 different statements. I want to decide if it's always true, sometimes true, or never true. Okay, a rhombus is a rectangle. Is that always true, sometimes true, or never true?
Never.
Never? Why do we say never?
Because it has 4 congruent sides.
Yeah, okay, so somebody else said sometimes. Okay, Ian, why do you say sometimes?
Because a square will always be a rhombus, so therefore a rhombus is sometimes a rectangle.
Yeah, a rhombus is a rectangle. That sometimes could be true. Okay, it could be true if it's one specific shape that you have. What shape could you have that you could consider it a rhombus, but it also is a rectangle at the same time? There's only one shape. A square. Okay, if you had a square, technically a square falls under the rhombus category. Okay?
Where was the square?
But a square also falls under the rectangle category. So if your shape was a square, that's an example where it could sometimes be true. A rhombus could be a rectangle, only if you had a square. So sometimes. Okay, an example where it wouldn't be true is if you had this shape. Okay, that's a rhombus. Okay, so in that shape, you have a rhombus. It's definitely not a rectangle. So in that case, it's not true. Okay, that's why sometimes that statement's true. Okay, a parallelogram is a rectangle. A parallelogram is a rectangle. What do you think? Is that always true, sometimes, or never?
Sometimes.
Sometimes. Somebody give me an example when It's not true.
Then it's not rectangle, it's a rhombus.
Yeah. Okay. Basically, this is saying if I tell you have a parallelogram, does that mean it has to be a rectangle? Is that the only choice? No. Could be a rhombus. Okay. So this statement is sometimes true. Okay. If I get stuck when I try to figure these out, sometimes I put the word like have to. Okay. If I have a parallelogram, does it have to be a rectangle? No. Could be something else. Now, are we going to reverse that? No, we're going to... What if I switch that around? A rectangle is a parallelogram. That's always true. Okay, a rectangle is always under the parallelogram category. That would be always true. Okay, now, what if I said to you, a rectangle is a pentagon? That's never true. Okay, pentagon has how many sides? 5. Okay, so a rectangle is not a pentagon. Okay, that would never be true. No. Okay, how about number 3? Okay, a square is a rectangle.
No, always, never. I thought a rectangle was a square, but a square can't be a rectangle.
Well, let's think. What's our definition of a square? 2 things.
90-degree angle.
4 right angles, yeah,
Congruent sides.
and 4 congruent sides. So if you have a shape with 4 right angles and 4 congruent sides, would that make it a rectangle as well? Yes. It's always true. A square is even more specific. It's like saying to you, if you live in, start with a small category and then go bigger. If you live in Boston, do you live in Massachusetts?
Yes.
Okay? Yeah, that's, assuming there's one Boston. That's always true. Okay? If you live in Boston, that's the small category. That's always within the bigger category of Massachusetts. Okay? It's the other way around. You have to be careful. Think of something that's bigger and then go more specific. Okay? A rectangle in that diagram, it's higher up. It's more general. Okay? So when I say bigger, I mean think something general and then more specific. If you live in Massachusetts, do you always live in Boston?
No.
Sometimes. Okay? You might not. So this is sometimes true.
I wonder what the percentage is of that. What percentage of Massachusetts is in Boston?
Okay, but does that
Countries in the States.
does that make sense?
Boston, but Massachusetts is the population of Massachusetts.
Any question on that idea?
Of the map.
Okay, does anyone have any questions on that? It's a little tricky to kind of think about, but once we draw a diagram, I think once we do trapezoids tomorrow, we're going to make a diagram that kind of has lines connecting it like the one on the side. Then I can show you it's very simple to figure these statements out. Okay? All right. Okay, so here's a rectangle. Okay, and I want to basically know, what else do we know about it? Okay, we know that it's a rectangle. Anybody think of anything else you know about that shape because it's a rectangle?
It has 4 90-degree angles that you can tell to the squares, 4 congruent sides. Well, not congruent, but it has 2 sets of parallel sides.
Okay, let's say that. Okay, we don't want to say anything we know by the definition of a rectangle. Okay, I want you to tell me things that would also apply to it because it's another type of shape. Okay, rectangles are a certain shape. All right, so what did you say? It's what?
It has 4 90-degree angles because
Yeah.
of the boxes, but it has 2 parallel sides.
Yeah, we know it's got 4 right angles because that's the definition. Okay, so we know that. But it does have 2 pairs of parallel sides. How do you know that?
Because I would just guess
Anybody tell me why? How does he know that it has two pairs of parallel sides? It's not marked that way.
It's also a parallelogram.
It's also a parallelogram, so let's kind of keep going with that idea.
Perpendicular.
What else do we know about that? Yep.
Opposite sides are congruent.
Yeah, opposite sides are congruent.
Has perpendicular lines.
It has what?
Perpendicular lines.
What do you mean?
I thought that was where like two things make a right angle line.
Right, so we've got four right angles, but that's the definition of a rectangle. So we know that. So I'm looking for what else do we know?
Oh, my bad.
That's okay. Yeah.
Sorry.
So we got opposite sides are congruent. What else? You can think of at least three more things. We'll just name a couple.
Consecutive angles are congruent. Or sorry, or supplementary.
Consecutive angles are supplementary. Consecutive angles add up to 180. All right, so that's good. And somebody give me one more thing. How about something about diagonals? We haven't said anything about
Oh,
diagonals.
D is diagonal to B and C to A.
So what's true about the diagonals? Go ahead.
They intersect.
They intersect in a special way.
But yes, well, two are big and one.
They what? They bisect, yes. Okay, so remember, guys up here, please. The diagonals don't always bisect in every shape. Okay, we drew a trapezoid, they don't. In a kite, they don't. Okay, but in a parallelogram, they do. Okay, so we'll learn those other shapes later on, but that's good enough. Okay, so that's four other things you know about it. All right, so remember a corollary it's kind of like a theorem, except it's an idea it's almost too simple to deserve to be called a theorem. Okay, there's another theorem that's too similar to this that I'm about to write, so we call what I'm about to put here a corollary. Okay, a quadrilateral is a rhombus if and only if. That's what IFF means. If and only if. It has four congruent sides. Okay, what does that mean? That phrase, if and only if.
Can only be a rhombus.
Does anybody remember what that's called?
That's what if and then.
So, yep, it has to do with chapter 2 when we did if then. But what is that phrase? There's a special word that summarizes what kind of statement if and only if is.
I remember us talking about this, but I can't remember.
Anyone remember what that is? If and only if. Okay, we're getting closer. It's a certain type of conditional that's true in two directions. Meaning you can read this. A biconditional, yes. Okay, what this means is you can read this statement forwards and backwards. Okay, you can say if a quadrilateral is a rhombus, okay, then it has four congruent sides. Or if a quadrilateral has four congruent sides, then it's a rhombus. Okay, you can read that forwards and backwards. Okay, any question on that? Okay, so here's another statement about a rectangle. And it's another biconditional. Okay, meaning you can read it forward and backwards. So if a quadrilateral is a rectangle, it has four right angles. If a quadrilateral has four right angles, then it's a rectangle. This is very, very similar to the definition, okay, except now we're reading it forward and backwards. Okay, and the last one, if For quadrilateral, it's the square corollary. Quadrilateral is a square if and only if it is both a rectangle and a rhombus.
Oh, I think it is.
So a quadrilateral is a square if and only if it is both a rectangle and a rhombus, meaning it has to have the 4 right angles and it has the 4 congruent sides. And so there's really nothing new here. Okay, you pretty much could have gotten all these corollaries from the definitions. That's why it's a corollary. It's not really anything that new. It's just kind of rewording something you already know. All right, so we'll start out with a couple easy kind of just calculation problems, and then we'll try to do 1 or 2 proofs, and I'll try to help you with them a little bit. Okay, so in the diagram, this is rhombus PQRS. They want to know the value of y. Okay, how would I find that? How would I figure out what y is there? Or first, before we even figure out y, somebody tell me what fact about a rhombus is going to be very helpful here. Yeah, Connor?
2 pairs of congruent sides, so that means we're going to do 5y minus 6 plus 5y minus 6 plus 2y minus 3 plus 2y minus 3, and then we're going to divide by blank here.
So we got to have an equal sign in here somewhere. If we just have an expression, like let's say you had something like 2x plus 6 after you add a bunch of stuff up and then you divide by something, all you're going to get is another expression. All right, so anybody tell me what, that's a good guess. What fact is really helpful here about a rhombus? Specifically about a rhombus. Be more specific than a parallelogram. Yep?
4 congruent sides.
Yes. Okay, that's very important.
Mr. Hager, couldn't you technically still have a rhombus though if you just elongated one side and curved it?
Curved it?
Yeah, I mean not curved, but like slanted it, you know what I mean? You could just elongate one, like 2 sides and then still be a rhombus.
Well, it would be a rectangle if you made 2 of the sides longer. Well, I'm not, sorry, not a rectangle. It would just be a parallelogram. Like if you just elongated 2 of the sides and kept the other 2 the same. These would still be the same, these would still be the same, but then it would be a parallelogram. All 4 have to be the exact same length to be a rhombus. Yeah. There's no other way to draw a rhombus other than like a diamond-looking shape. Yeah. Okay, so now that we know all the sides are congruent, anybody tell me how can we set something up here as an equation? Yeah?
You do 2y plus 3 equals 5y minus 6.
Yeah. We know that the side on the left and the side on the bottom are the same length. Okay, so set them equal. 2y plus 3 equals 5y minus 6. Okay, now Morgan, what would be my first step to solve that? Okay, so what's our goal here? What are we trying to do? Yeah, we're trying to get y by itself. Okay, so first thing I would try to do is get all the things that are maybe y's on one side. Okay, I try to get all the things that have a y attached to them on one side. Okay, you could subtract 5y from each side. What else could you do? Subtract what? So go back to your idea with the y's. I like that idea. But instead of putting all the y's on the left, let's put them on the right. Just because that'll keep it positive. Then we won't have a negative y. So how would you move 2y to the right? This is a positive 2y, right? Subtract it. Does everybody see why I decided to do it that way? If I move the 5 to the left, I'm going to have 2 take away 5, and I'm going to get negative 3y. Then I got to deal with that negative. This way, these cancel, and I get 3 equals 3y. No negative. Minus 6. Okay, how about Sarah? What's my next step?
Add the 6.
Yep, we're going to add the 6. So if we're going to put all the y's on the right, we're going to put all the things without y's on the left. 3 plus 6. So I get 9 equals 3y. So Kiera, what's y? Yeah, y is 3. Okay, and I think that's all they wanted. What was the value of y? Okay, now Olivia, how long is the left-hand side in that rhombus? 9. How about the bottom side? 9. The right side is 9, the top side is 9. All the sides are 9. So now a question I could say, what's the perimeter of that rhombus? You'd have to take the 3, plug it back in, get one of the sides, and just multiply by 4, because they're all the same. They're all 9. Good. Okay, any question on that? All right, so now I'm going to take a look at some theorems just about the diagonals. Okay? Well, we already know the diagonals bisect each other. Okay, that's true for a parallelogram. But they can bisect each other in different ways. Sometimes the diagonals will be perpendicular. Okay? They bisect and they're perpendicular. That'll happen in a rhombus. Okay, so in a rhombus, if you draw in your diagonals, they always meet at a 90-degree angle. Okay, and it doesn't matter how large or small you make the rhombus. You make it any size you want. So let's just... Okay, I can't draw it like that. That's not a rhombus. That's a parallelogram. Okay, if you draw in your diagonals, it'll always be a 90. And if you have one right angle, how many do you really have in that middle part? 4. If 2 segments are perpendicular, they intersect to form 4 right angles. Now, would that be true in a parallelogram? If I said to you, in a parallelogram, the diagonals are perpendicular, would that always be true, sometimes, or never? Sometimes. Okay? If you have a rhombus, that's when they're perpendicular. Okay? If you just had a parallelogram, okay, drawn like this, if you draw the diagonals in, they're definitely not perpendicular. They don't meet at a 90-degree angle. Okay, another theorem about the diagonals in a rhombus. It says a parallelogram is a rhombus if and only if each diagonal bisects opposite angles. So now we're not just saying this. We already know this is true. That angle and that angle are the same. But what we're saying is when you draw the diagonal in, it cuts that into 2 equal parts. Okay, and this is also 2 equal parts. And same thing on the other side. Cuts that angle into 2 equal parts, and that angle into 2 equal parts. Okay. Any question on that versus the one we've studied before? The one we did before basically says this. That's the same as that. That's the same as that. We looked at the big angle. Now we're looking at what happens when we bisect it. I think this will be our last theorem for today, and then we'll do some examples. It says a parallelogram is a rectangle if and only if the diagonals are the same length. They're congruent. This idea is actually used when they build things. Anybody know where they do this? Measure the diagonals and see if they come out the same length? Connor?
On TVs, on flat screens.
When they measure the diagonals? Okay, so I think when they talk about the size of the TV, they might talk about the diagonal, but I'm thinking of something in construction, where they actually measure the diagonals when they're building something to make sure that something happens.
Foundation.
Okay, you could do it in a foundation. Why would you want to, so if you had your foundation poured for your house, why would you want to measure the length of each diagonal? What would that tell you about the foundation?
It's a rectangle?
Yeah, basically that your angles are 90-degree angles. Okay? I was also thinking of a doorway. Okay, when you have a doorway, if you measure the diagonals in it and they come out the same, that means your doorway is square. If one diagonal comes out longer than the other, then your doorway is a little crooked. It's more like a parallelogram. Okay, it could be a little off. Okay, so that's a quick way if you want to measure and make sure that you're building something that has 4 sides and they're all perpendicular, just measure the diagonals. And that'll show that they're perpendicular. But yep, you can definitely do that with the foundation too. Okay, so as I said earlier, what I think I'll do is I'll put together a sheet that has all the theorems and properties on it. So that way you'll have one page, you can use it on the test, and you won't have to try to memorize every single property. In fact, if you look on your book on page 350, it says you're building a rectangular doorway for a theater set. And they ask, how can you show that the doorway you're building is square, that you built it correctly? What if I had a doorway that I built, and I measured this side is 3 feet, that side's 3 feet, 8 feet, and 8 feet? Would that be good enough? Would that prove that my doorway is rectangular? What do you think? Measured the top, you got 3, the bottom, you got 3, the left and the right, you got 8. Yeah? Yeah. This would prove you have a parallelogram. That's all that this proves. You could have a doorway that's slightly off. And that would still be 3, 3, 8, and 8. Okay. Wouldn't be that obvious, but that's the idea. Okay, so you got to measure the diagonals. It's the only way to prove it's square. All right, let's look at example 4. Okay, for the rest of today, we're going to just focus on theorem 6.11. Okay, we're going to try to show that this statement is true in both directions. Okay, so let's start with this one. Okay, first way, we're just going to prove it one way. Okay, it says you're given a parallelogram, and I'm telling you AC is perpendicular to DB. Okay, before we even write statements and reasons, let's start drawing on this diagram. Let's mark some things that might help us. Okay, I'm going to mark what's given. Yeah, let's mark the given. AC is perpendicular to DB, which basically means you've got 4 right angles. Okay, if they're perpendicular, you get 4 right angles. Now, how about this fact? ABCD is a parallelogram. What could I mark there?
That means that the opposite sides are parallel,
Opposite sides are parallel. Yep, we could mark that.
opposite sides are congruent.
Opposite sides are congruent. Let's mark that. Because my goal, I'm trying to prove triangles are congruent here.
Diagonals bisect.
Yeah, let's mark the diagonals bisect. And let's see if that's enough information. Okay, so opposite sides are congruent. Diagonals bisect. Okay, we know all kinds of other things. Opposite angles are congruent, but that's not going to really help me because that angle covers 2 triangles at the same time. I'm looking for things that are just true in these 4 little triangles. All right. And now before we start even doing statements of reason, let's try to see where we're going to go with this. Well, my goal is to basically, I want to try to show somehow that this triangle and this triangle are congruent. And then I want to show that this triangle and this triangle are congruent. And then if I can show this one and this one are congruent, then they're all congruent to each other. Well, if I've got 4 congruent triangles, that means DC, CB, BA, and AD are all the same length, which means I have a rhombus. Okay, so that's what I'm trying to prove somehow. Okay, so let's start writing down some of what we did, and then see if we can somehow tie in congruent triangles. All right, let's look at our statements. AC is, let's write the given. Okay, everything that was given. So ABCD is a parallelogram. Just abbreviate it like that. AC is perpendicular to DB. That's all given. Okay, statement 2. Let's start writing down the sides we marked. Okay, AB is congruent to AC. Or actually, you know what? We're going to need a name for that midpoint. Okay, let's just call it X. Okay, so now we can say AX is congruent to CX. I could also say BX is congruent to DX. What's the reason for that? Yep.
Because parallel.
What about it though? In a parallelogram, the
Diagonals.
yeah. So the reason, if you know the theorem number, you can write it. I don't expect you to know those though. So in a parallelogram, the diagonals bisect each other. Okay, we also wrote down, let's see, AB and DC were congruent. We also wrote that AD and CB are congruent. Okay, and that's because we had opposite sides are congruent in a parallelogram. So a lot of your reasons are going to start out in a parallelogram. Opposite sides are congruent. Okay, now we could write down, we marked all 4 of these as right angles. I'm okay, we can leave that part off because that's, if you have 1 right angle and 2 things intersect, you automatically have 4. Okay, we don't have to get that specific. But now we have to try to start proving triangles are congruent here somehow. Anybody see a way we can start proving? I think that there's no question I could prove the top and the bottom one congruent by side, side, side. I could also prove the left and the right one congruent by side, side, side. The trick here is I need to prove this one and that one. Which actually I don't really think is that hard to do. Anybody see how we could prove off the 2 that I checked are congruent? Because then if you prove that, it really proves DC and CB are the same. Even though we have them marked with 1 and 2 tick marks, if we can prove those triangles congruent, then they really are the same. Yeah?
Supplementary angles.
You know what? I don't even think we're going to need to write anything else about angles here. We can do it with just what we've written.
Oh, they share a common line.
Okay, they share a common side, side XC. So we got a side. Do they have an angle in common?
Yes.
Yeah, they both share a right angle. So we have a side, we have an angle.
And DX and BX.
Yeah, we got another side. So we have a side, angle, side. So those 2 triangles are congruent by side, angle, side. Right? And we've already listed all that individual information. DX and BX congruent. I guess we can write down XC is congruent to itself. That's what property is that when we say something's congruent to itself?
Reflexive.
Yep, reflexive. Okay, so we just named that side. We already have the other 2 sides. Okay, we already marked those angles being the same because they're both 90. Technically, we should say that. DXC and CXB. We could say they're both 90, which means they're both right angles, which means they're both the same. Okay. Just to simplify it so we don't spend forever. Otherwise, I'm going to have to add 3 steps just for that one part. Okay. So now let's just say that the 2 triangles are congruent. So DXC is congruent to triangle. And what would be the order I would name it in? So I did D, X, and then C. Yeah, Connor?
BXC.
Yeah, BXC. If you're ever not sure, just compare the letters and make sure they match up. Do you want DX and BX to be the same? Yep. Do you want XC and XC to be the same? Yep. How about DC and BC? Yes. We want DC and BC to be the same. Okay, and the reason? Side, angle, side. Side, angle, side. Okay, so now we've proven those 2 triangles are congruent. So I can say DC and BC are congruent. Does anyone remember the reason for that? Once you prove 2 triangles are congruent? About there, it's the letters. 5 letters.
C, P, C, B, C.
Yep. once you prove corresponding parts of congruent triangles are congruent. Okay. So remember, our goal is to show that DC is the same as BC, which is the same as AB, which is the same as AD. So I'm going to put a star there because that one's important. Well, if I know, let's see, DC and BC are the same, is BC the same as anything else by what's already marked there? Yeah, it's already the same as AD because of what we have marked. And how about DC? Is DC the same as anything else by what we already had marked? AB. Okay, so now we just need to write that. But we've already shown that all four sides are congruent. Okay, we just have to kind of write it down. So I'm going to put, well, you know what I'll do? I'll highlight, if I can highlight, the important part. Okay, so we've shown DC and BC are the same. Where did we say DC and AB are the same? Right here. Okay, so we got that. And where did we say CD and AD were the same? Right there. Okay, so now I'm going to put all three of those statements together. It's kind of going to be like one giant substitution or transitive property. Okay, so we've got DC is also the same as AB. Okay, and we know that let's see, DC, AB, that's what I had up above. And we also know that DC is the same as BC because of what I said in statement 6. And we also know that BC, or CB, is the same as AD because of what I said in statement 3. Okay, did I say all four sides? We got AB, BC, CD, and DA. Yep, I got them all. So the reason for that was really substitution. Or you could also look at it as transitive. It's kind of confusing, but I basically said it in the 3 statements that I highlighted. So basically, we proved it was a rhombus. Okay, not the most formal proof. We didn't write out every little detail. If you did that, this would probably be like 13 or 14 steps. But I kind of just tried to capture the big idea for you, proving triangles are congruent. And I highlighted the real important steps. Okay, any question on that? Okay, so that's the hard proof. Okay, proving what we just did. If it's a parallelogram, then proving it's a rhombus. Okay, the last one we'll do, kind of the other way around. I'm going to tell you that it's a rhombus to start with. This time I want you to prove the diagonals are perpendicular. Okay, first thing I'm going to do, I'm just going to write down what was given. Okay, that it's a rhombus. Reason, that's given. What could I say because it's a rhombus? A couple things we could say, yeah? Okay, we have 2 pairs of parallel sides. Let's go even more specific. Things just about a rhombus. Ian? Yeah, it's got 4 congruent sides. Okay, we can write down that all 4 are congruent. I don't think we're going to need all 4, but let's write them all. So AB is congruent to BC, which is congruent to CD, which is congruent to DA. I really think you only need 2 of them to prove what we have to prove. And the reason, that's the definition of a rhombus. Okay. What else? Let me label this midpoint. We'll call it X again. You want to tell me anything else that's true there? Yeah? Yep. AX would be congruent to CX. And that's because it's a rhombus, which means it's a parallelogram. The diagonals bisect. So AX is congruent to CX. It can't hurt to write it down. It might not help, but I think in this case it probably will. Okay, good. Anything else you want to say? Well, we mentioned AX and CX. Yeah, go ahead. Yeah, we could also say dx and bx. Same. It's going to be the same reason. What's the reason? In a parallelogram, diagonals bisect. I think we're almost there. Anybody see something I could say now? I think we've labeled as much as we need to about sides and angles. Now we need to take everything we've labeled and say something. How about just looking at these 2 triangles? This one and that one. What do we know about those 2 triangles now? Yeah. Yeah, they are congruent. Okay, the top one has a side of 1, 2, and 3. The one on the right has a side of 1, 2, and 3. Okay, so those 2 triangles are congruent. Okay, let's write that down. So triangle, let's say DXC is congruent to, now just name your letters carefully. Well, Alyssa, how would I name those, the other one? DXC and BXC. Yeah. What's the reason? Why are those 2 triangles congruent? Yeah. Yeah, they have 3 sides all in common. Side, side, side. Okay, now my goal here, remember, is to prove something about those 2 segments, those 2 diagonals being perpendicular. Okay. What do you know about angle DXC and BXC? We know something about them now. Yeah?
90s.
We don't know their 90s yet, but we do know something a little bit more general. We at least know that they are Not congruent, yeah, we know they're congruent, okay, because of CPC/TC. So whatever they are, they both have to be the same. So angle DXC is congruent to angle BXC. Can somebody tell me something else we know about them? They're the same, and they also make what kind of angle? They make a 180-degree angle. Okay, so now we're kind of getting there. We've got two angles that are the same, and they add up to 180. Okay, that's not leaving us too many options about what they each are. Okay. So, you know what? Let's write it like this. Okay, the measure of angle DXC plus the measure of angle BXC equals 180. Reason? They form a straight angle. They form a straight angle. Okay, now what I'm going to do is I'm going to change this using what I said in statement 5. BXC and DXC are exactly the same thing. So I'm going to change BXC to DXC, okay, because of statement 5. That's substitution. Okay, so the measure of DXC plus, now don't put BXC, put what it's equal to, DXC. That equals 180. Okay, that was substitution. Now, what can I write there? The measure of angle DXC plus the measure of angle DXC. How many measure of angle DXCs is that? 2 of them. Okay. So step 8, I'm just going to simplify what I have in step 7, and this is going to lead me to the answer. So 2 measure of angle DXCs equals 180. So we just simplified, kind of like combining like terms. And now how would I get angle DXC by itself? And get that 2 on the other side. Okay, divide each side by 2. So how much is the measure of angle DXC? It has to be 90. You divide each side by 2. You get 90. That's the division property of equality. And now my last step is basically to say what I've proven. AC and BD are perpendicular. Okay, and the reason? Well, definition of perpendicular lines. We formed a right angle, which means these are perpendicular. One step we could add, but I'm not going to add it in, is to say that if angle DXC is a 90, angle DXC is a right angle, which then means it's really perpendicular. Okay, but I don't want to make it any longer. Okay, but that's the kind of the basic idea. A lot of little steps. 6, 7, 8, 9, and 10 were all very short little steps. Main part of this proof was really step 4, showing you triangles are congruent. Okay, so it's kind of definitely a couple tough proofs. Okay, any questions on those proofs? Okay, in the homework, mostly I'm going to focus on the examples, maybe one proof. Okay, so the homework will be on 351. 13 to 29 all, okay, 33 to 37 all, and then 44, 46, and 55. Okay, a lot of the problems are either calculations or like the sometimes true, always true, never true. And 46, I believe that's the only proof.